In this video, we're going to be learning about a new type of functional group that are what we call the amines, which we can recognize as being distinctive because rather than alcohols that contain oxygen as the central atom, all amines contain nitrogen, which gives it very different physical and chemical behaviors compared to the oxygen-based functional groups. This compound here is the simplest example of an amine, which is actually very straightforward to name, as long as we know that all amines are given the suffix amine to indicate the presence of an amine functional group. If only all of organic chemistry were actually this simple. We can see that this amine only has one carbon, which means that we designate it with the prefix meth. And since this cannot form a double bond with another carbon because we only have one carbon, the base molecule here is methane. And then if we add the suffix amine here, we have the name for this compound, methenamine. Now, amines can get significantly more complex than methenamine here, including a unique classification system which refers to the number of bonds the central nitrogen of an amine has to carbon. So, for example, methenamine is what we call a primary amine, which we designate with a 1 and a degree sign here as the short form, because there is only a single nitrogen to carbon bond, although as we see with the amines below, this is not always the case. If the amine is only bonded to one hydrogen and has two bonds to two different carbons, as we see here, this is what we would call a secondary amine, given the short form that looks like this. Naturally, if there are three bonds to three different carbons, this would be called a tertiary amine, which we would represent with 3 and a degree sign here. And nitrogen, due to the fact that it has a lone pair, actually has the ability to make coordinate bonds where the lone pair actually moves and forms a single covalent bond with another element, which is how we can actually end up with quaternary amines like this, which are easily identified because the nitrogen has a positive charge indicated as to when this lone pair moves away from the nitrogen, although quaternary amines are relatively rare. Now, fortunately, the naming system that we're going to explore doesn't actually involve naming secondary, tertiary, or quaternary amines because the naming system gets a little bit cumbersome. So the examples that we're going to look at are all primary amines, and because amines are a functional group, by default, they define what the parent chain of the molecule is going to be, and therefore the carbon number that refers to the location of the amine is generally kept as low as possible unless a more important functional group is present, but we will not be looking at that in this video. So for example, if we take a look at the first amine here, normally it would be ambiguous as to whether carbon 1 was on the left or the right side of this molecule. However, since the amine is clearly leftward rather than rightward, we can identify carbon 1 as being here and therefore identify our parent chain as being 5 carbons long, which would therefore be pent, indicating 5 carbons. There are only single carbon-to-carbon bonds, meaning that the basis is pentane. And because the amine is located on carbon 1, but theoretically could be on any of these carbons here, we add the location number 1 before the suffix amine to indicate that our parent chain is defined by the amine functional group. And from there, the remainder of this molecule remains identical. On carbon 1, sharing carbon 1 with the amine, we have a bromo alkyl halide. We have 2 chloros up here, so we would have on carbons 2 and 4 a dichloro, and then our final functional group would be the ethyl functional group here on carbon 3. And if we list them alphabetically, which I've actually already done, bromo precedes chloro, which precedes ethyl. So if we write the side chains in order, we would write 1 bromo coming first. Secondly, chloro comes after, 2,4 dichloro. followed by our ethyl, so 3-ethyl, and then we simply write the rest of the parent chain here, which would be pent, indicating that there are 5 carbons, ane, indicating that there are only carbon-to-carbon single bonds, and the suffix amine preceded by the location 1 to indicate that that is where our amine functional group is in this molecule. So once again, as long as we know that the suffix amine defines this as the functional group that defines the parent chain, the rest of the naming system remains identical to what we've seen before. So before we end the video, if we take a look at a drawing example, we can see that our parent chain has 7 carbons and is an alkane, so it only has single carbon-to-carbon bonds, and that the amine is actually found at carbon number 4. So if we go 1, 2, 3, 4, 5, 6, 7, our amine, under the assumption that it is a primary amine, would be located here. You can either write it as NH2 like this, or if you want to show the explicit nitrogen to hydrogen bonds, you can write it like this. Either one of these is perfectly acceptable. On carbon 3, we have a chloro, which would be 1, 2, 3 here, and on carbon 5, we have a fluoro, 1, 2, 3, 4, 5, which we would write there, and this is a fairly easy example of a name to structure question here. Before the next video, where we take a look at more complicated oxygen-containing functional groups, you can take a look at the practice problems below, testing your knowledge of how to name and how to draw the structures of amines, as well as combining your knowledge of how to name and draw the structures of the first 2 functional groups, amines and alcohols. So give a few of these a try before introducing yourselves to the more complicated oxygen functional groups afterwards.